Hello everyone. So in this video, I'm going to be teaching the basics of linked list. Just explain what linked list is in general and the most basic operations of linked list. And I'm going to illustrate with examples and show you the code afterwards. So now what is a linked list? So essentially a linked list is a collection of objects or data elements that are linked to each other. That is what a linked list is, and it is an ordered list. So that is essentially what a linked list is. So if you can see here, this entire thing is what we'll be referring to as a node. Now, a node will have two parts. One will be the data that it's storing, and the other part, this part, will be the location for storing the next node in case of a singly linked list. So now this data can be anything. This is one common confusion that beginners have, because usually all examples they just show an int data, and that is somewhat misleading. This data can be anything. It can be, you can have a class, you can have strings, you can have a combination of things. This data can be anything. The whole concept is that it has a singly linked list has two sections, one section to store the data and another section in the form of a variable, a pointer variable, to store the location of the next element in the list. So this element will actually store the address of this particular node so that we know where this particular node resides. This node can reside in any part of the memory. So one thing, I am assuming whoever is watching this video that they have a basic understanding of pointers. If you don't, I would recommend you to pause this video, go watch or go learn about pointers, and then come back and resume this, because it will be easier for you. Without knowledge of pointers, you won't be able to grasp the concepts as easily. So this is about a singly linked list. The below representation is of a doubly linked list. A doubly linked list is pretty much the same, apart from the only difference is that apart from data, instead of just one um, location for storing the address of the next, we have another location for storing the memory of the previous one as well. So like this, so for this node, we can see that the next data it is storing here, and the previous one it is storing over here. So this is essentially what a linked list is: an ordered list of objects or data elements that are linked together. End of story. Now the basic operations that I'm going to be covering in this video is insertion, deletion, and displaying the entire linked list or traversing through the linked list. The concept is the same. One thing to note, I am just going to cover the basic operations in this video. I will also be doing videos that cover advanced operations. By advanced operations, I mean things like reversing a linked list, finding the middle element, finding if there is a loop, finding the point of the loop, things like this, which are usually asked a lot in coding interviews, or um, they are required for a very basic conceptual understanding, but are a little advanced. They're not at basic operations. So for them, I'll be creating individual videos and uploading them. So let me show you the basic structure that we're going to be following in the code as well. So this is where I've defined my node. I am assuming that my node is going to be collecting student data, so I've just included roll number and name. And this is for a singly linked list, so we just have one pointer. And then I've created a class for a singly linked list where I'm storing two pointers, which is head and tail. Head is going to point to the first location of the linked list, and tail to the last location of the linked list. Um, just to show you an example, this is how it's gonna look like somehow. Head is gonna, so this is my linked list. Head is gonna point to the first element and tail to the last element. Yeah, and then so then we just have head and tail, and we have functions, and yeah. Now let's come to the first operation that we're going to be covering, which is insertion. Now, inserting can have three cases in general. The first case is when the list is empty. In that case, your head and tail are both going to be null. They're going to be pointing to nothing since your list is empty. The expected state after insertion should be something like this. We have a node here, a single element in the list, which is pointing to null. The next element is pointing to null because there is no next, and the head and tail both point to this element because there is just one element in the list. Now, the second case is when we initially have only one element. So um, over here, head and tail are going to be pointing to this element, and we want, oh, one thing that I missed here is that this should be pointing to null. So this thing should point to null, and then I have this, and then the expected state is that the insertion happens. So one thing, by the way, I'm just showing these diagrams based on insert and front. I'll show you the code for insert at back as well, but the concept is generally going to stay the same. So yeah, the expected state is that one more element is inserted in the beginning. Head now points to the new element, and tail continues to point to the same element because this is the last element, this is the first element. And the third case is when we already have a list with multiple elements. So this is the initial state. Head points to the first element, tail to the last, and in between we have two more elements. And this is the new element that's been inserted, and head will now point to this. This will point to the old head, and tail will continue to point to the same element. So this is essentially what the three cases are that you have to cover while you look for inserting into a linked list. Now, a lot of people, what they do is they see that, okay, fine, we have to insert. They just rote memorize the code and they go and write it. That's not the way to go. You do not need to rote memorize anything. As long as you understand the concept, you will be able to code it properly. And if you are having troubles, this is sort of like a cheat sheet for you. You can use this like a cheat sheet. These are the basic steps that you need to do to write a function to insert into a linked list. What are the steps? The first step is that you create a new element. Okay, you have to insert a new element. What do you need to do first? The first step is that you need to create a new element. Next, okay, you have created a new element, but it is currently empty. So what do? You assign data to it. Whatever you want to store in it, you assign the data. Next, wherever you wanted to point to after insertion, you do that assignment. You assign its next pointer to wherever you want it. And the last step is that you reassign head and or tail based on whatever insertion has happened. And because the state of the list is going to change, so you need to check whether you need to reassign head or tail, and you need to assign them appropriately. So I'll take up an example now. So this is my list, and now essentially what I would want to do is I would want to insert an element in the beginning. Let's say I want to insert an element in the beginning. So step 1, create new element. That's it. This is step 1. I have created an element, done nothing inside it. Now step 2, I will add the data. Right. Now step 3, I will assign the pointer location. Now what is the pointer location going to be? So when I am inserting this in the beginning, I want this to point to the current head, because now this is going to be the first element, this is going to be the second element, the third, fourth, and fifth, so on. So I will make this point to the current head. And fourth, what I have to do is I have to reassign head and or tail based on what the requirement is. Now tail will go unmodified because this last element stays as it is. So I'm going to strike off head, and I'm going to assign head over here. So we have a new linked list. This is the first element, head is assigned here, and this is the second element, third element, fourth element, fifth element, and this is tail, and this points to null. So as I said, just remember that cheat sheet, and this is how you insert. Now let's see if we want to insert in the back. How do we do that? So once again, you follow the same steps. Step 1, create a new element. Right, so you have created a new element. Now you add data to it. So this is my data. Next, you assign the pointer location. Now note, insert at back would mean that nothing is after it. It's the last element. So this should be pointing to null. And step 4, reassign head or tail. Oh, one more thing. So while inserting and beginning, I don't have to take care of reassigning this. I just need to assign this pointer. Over here, I will also have to reassign this. So reassigning pointers are going to be a two-step process. One, assign this as null, and the current tail will now point to the new element. And step 4, you reassign head or tail. Head will stay unchanged. Tail you will remove, and you will point tail to this new element. So this is essentially how insertion is going to work. Now let's see the code to understand how this works in terms of code. So I think that after this basic understanding, you should be able to understand the code very easily. So we have the code here, right? So insert front. So again, step 1, create a new node. Step 2, assign data. Step 3, temp of next is equal to head. So yeah, this is the step 3. You are assigning the pointer. This is essentially this step. This step, temp of next data. And now why this condition is required. So let's say I do not have any elements in my list right now. So in that case, head is going to be null. So I'm already assigning head equal to temp over here, which is this step, head to temp. But I also need to assign tail to temp in case it is just one element. Remember the first step? We need to assign tail over here as well. So this is what this part does. And that is it. This is your insert in front method. Next, insert in back. Step 1, create a new node. Step 2, assign data. Step 3, you assign the pointer location. And this is where we do tail of next is equal to temp. Now, this note we are only going to do in case tail has a particular value. What that means is that there should be at least one element. If there is no element, then doing tail of next will not make sense because you are trying to access a variable of what will be null. So that's why first we check if head is null, which means if the list is empty, then we assign head to temp. If it is not, that means there are already elements, tail already has a value, then tail of next will be temp. And of course, tail will be temp. So we are assigning tail to temp. This is my temp in this case. So that's it. This is how you insert into a linked list. Now let's move on to the next operation. So now let's come to the next operation that we're going to cover, which is traversing a linked list or displaying it. So basically displaying is going to be traversing the linked list one by one and then displaying that particular element. That's what display is. That's why I've put display under traversal itself. Now, a lot of times, what the mistakes that beginners do is that they see that, okay, so how do I traverse a linked list? It's a singly linked list. I obviously cannot come back. I can only go forward. So, one second. Yeah. So I cannot use tail at all over here. So, but I can obviously use head, right? If I have head, I can go one by one, like head of next. From head, I can access this element. And from this element, I can access this element. From this element, I can access this element. This element, I can access this element. And that is the whole concept of linked list. From one element, you go on to the next element, to the next, to the next, to the next. And that's basically how you traverse. That's the whole concept. So the mistake, as I was saying, that people do is that they traverse head. Now, when from here you do head equal to head of next, what's going to happen is head is going to come here and this is going to go away. So, what will happen as a result is that you're going to completely lose track of this. This will not exist for you anymore. But basically, this will exist somewhere in the memory, but you won't know what that memory location is. So essentially, the data will get lost. So what is the solution for that? And this is why. So the solution is that we use a temporary variable. So the temp will start off as the same location as head, and eventually we'll do temp equal to temp of next. You come here in, then again temp equal to temp of next, temp equal to temp of next, and again temp equal to temp of next. And so this will run in a loop until temp of next is not equal to null. Just as simple as that. So this is traversal, and let me show you the code now. So this is the code for displaying. So yeah, the first condition that we're going to check, if the head is null, then obviously there's nothing to show. If it is not, then you assign a temporary node pointer to head. So now this is going to point to the same location that head points to, which is the first element. This is the state now. Now, yeah, so while temp is not, this is basically same as while temp is not null. We are displaying the elements and we do temp equal to temp of next. So temp equal to temp of next. We display again, then temp of next, display, next, display, next, display. Now when we do temp equal to temp of next, here temp will be assigned as null. So the loop breaks and we exit. And that is displaying. So now let's start with deletion. How to delete an element from the linked list. So over here, we are only going to be covering deleting from the front and deleting from the back. Deleting from the middle is essentially traversing to that particular element and then getting rid of that. If anyone has doubts on that, please comment. I can take up a separate video on that. So yeah. So in this case, the case one, list has just one element. So head and tail both point to that element, and the state after deletion should be that head is null and tail is null. Next, the list has two elements and we want to delete the first element. Head is the first element, tail is the second element, and the expected state we want it to be that there's only one element, which is this particular element, and head and tail both point to that element. Then the case 3, we have multiple elements. So here we have a list of 4 elements. Head is this, tail is this. You want to remove this particular, you want to remove this particular element. So we want, after removing, we want head to basically go on. We basically want head to get reassigned to this, which is what is happening over here. We delete this element, head is this, tail remains this. So these are the 3 cases. It's similar to insertion. So now cheat sheet for deletion. So, um, yeah, the first step, assign the node that you want to delete as temp. Next, reassign head and or tail, and finally delete the node. This is it. These are the steps that you have to follow. And if you follow these steps and remember these three cases, you will never be able to go wrong. Your function will always be correct. So let's see how that works. So let's say you want to delete this particular element. So step one, assign this as temp. So temp is now assigned to this. Next, what we're gonna do? We're gonna do head equal to head of next. So my head will now point to this. And which is why it is so important to use a temporary pointer to point over here before we assign head, so that this data element is not lost. We still have something to reference it by, which is temp, and now head is this. So this will essentially be my new list, and after I have this, I'm just going to delete this element. Simple. Now cases, now let's talk about the other two cases as well. This is the most simplest of case, wherein we just have wherein we have multiple elements. So let's see the other cases as well. So this is my second case, when I'm going to have two elements and I'm going to delete this. So again, in this case, what I'm going to do, assign temp, remove head, put head here, and delete this. So this will be my new list. Now let's take up the first case as well. Let's cover that quickly as well. We have temp here, and then head equal to head of next. So head is going to point to null, and then we need to check that if head is null, then tail should also point to null, and then we just need to delete this. So as simple as that. These are the three cases. Now let's look at the code. So this is the code for deleting. So yeah, if the list is empty, we cannot delete. So you assign the temp to head equal to head of next. If head equal to null, tail will be null, and then you delete them. As simple as that. I just showed you the three cases how they work. Step one, assign temporary node to head. Step two, traverse the next one. And if if this is basically if the list has only one element currently, so when we do this, head is going to point to null. In that case, you want tail to be null as well, because the list is going to be empty after you delete it, and then you delete it. Deleting from back is going to be a similar process. The only difference is that we are going to have an overhead. The overhead is that we're going to have to traverse to the last element. Let me try to explain this. So we have this, and I cannot directly delete tail, because what happens if I just delete tail, right? Everything goes. This is my new list, but the problem here is that this is still pointing to a memory location. So, and we need this to point to null. there is no way of coming back here. Since this is a singly linked list, we cannot go previous, we cannot do this, so we'll have to traverse one by one and come here, right? So now let's see how to do that. So so we'll traverse in the same way. We assign temp to head, then we traverse. So eventually we're going to come at a place where, so we are using priv and temp. So this is going to be priv and this is going to be temp. How are we going to do this? We're going to start temp from here, priv will be null, then assign priv to temp and temp equal to temp of next. So essentially how it's going to happen is that over here priv will be null, here temp is this. Now we do priv equal to temp, so priv will now point to this, and temp equal to temp of next, so temp will point to this. In the next step, again we're going to do priv equal to temp, so now priv will point to this and temp equal to temp of next, so temp will point to this, right? So this is essentially how deleting from back is going to go. So now let's see the code for that. So here we traverse and we come to a state after this loop where priv is this and temp is this. So then now if priv is null, what does this mean? This means that the linked list has only one element. In that case, we want the head and tail to be null both. Otherwise, we want priv of next to point to null. Right, priv of next to point to null, and we delete this entire thing, delete temp. And after this, we assign one thing that I forgot to do is tail equal to priv. That's pretty much it. And so this is linked list. If you want, you can see this in action as well. So I created a linked list of students. So by the way, this is the advantage of using classes. You can just, it's very easy. So I inserted back. So then the expected state is Rohan, so pull the guy. Then again, I insert in front, inserted back. So 0, 1, 2, 3, 4, 5. Then I delete two elements from the front. The first two elements are deleted. Then I insert another in the front, it gets inserted. Then I delete 4 elements from the back, only the first element is there. Then I delete an element from the back, then I try to delete another element from the back, but the element would be the list would be empty, so it can't delete. Then I try to delete from the front, same, it can't delete. Try to display the list, but the list is empty right now. I insert another element at the back, insert one at the front, and we have the final list. So this is linked list. Once more, I am going to be uploading advanced videos as well. Advanced videos. So this was basically basics of linked list. In those, I'm going to be covering a little more, basically a little more advanced concepts or questions that people ask, like finding a loop or finding the middle element, things like that, as I mentioned earlier. So if you like this video, please share it with your friends so that they can also understand. If you have any suggestions or if you want videos on a particular topic, please let me know in the comments. I will also be doing a video on trees similar to this, basics of trees, next week. So tune in for that. if you found this helpful and want to learn about trees as well. Thank you.